Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. So in the previous lectures, we discussed about the measures of central tendency, right? So we discussed about the mean, median, mode for group data and ungrouped data. So in today's class, we'll discuss about the measures of dispersion or measures of the variation, right? So what is measures of dispersion? We'll just come to know one by one. So this dispersion is a key concept in statistics that describe how the data values are varied, right? How they are spread out around the mean, around the central value. So look at this example. Now this is the 10 students we have, and this is the data of 10 students in marks in 3 tests: test 1, test 2, and test 3. So in test 1, all students got this 10 marks. All the students got 10 marks. So the average marks is 10. In test 2, some of them got 8, some of them got 9, some of them got 10, some got 11, 12, like that. Then again, if you take the mean, so you can just count the mean and you see that, okay, the mean is again 10. And the third case, in the third test, some student got 5, right? Some student got 10 and some student got 15 also. But again, if you take the average, you are seeing that, okay, the average value is 10 again. Right. So now if you just want to understand the data from the mean, although their mean is same, but they are varying, right? In the first test, it is different. The second data set, it is different. Third set, it is, yes, some student got less marks, some student got more marks, some got average marks, 10 marks. So only mean is not enough. Correct? So the test 1, as I said, the no variations is there. In test 2, some variations is there, and test 3, that variations is more. Therefore, the conclusion is we need to think some other kind of parameter to understand the data. So, measures of dispersion we'll talk about. What are they? Then some of its examples are like we'll try to find out the range of the data, then the variance, standard deviation, and few more. So even when the dataset have the same average, they may behave very differently. So in this case, dispersions help us understand the consistency, reliability, spread of data, which is crucial in field of like education, economics, quality control. We'll see these examples later, right? So one by one, we'll discuss this measures of dispersion. So mostly we'll have this 4 type of dispersion we'll discuss. One is range, next is variance or standard deviation, then quartiles or interquartile range, and the fourth is mean absolute deviation. These are all measures of dispersion. Sometimes we called it as like it's a measures of variations, and we call them as measures of dispersion. So you can name them in both the way. Now, what is a range? So the range is the difference between the largest and the smallest value of the data set, right? So from like in the previous example, range was for the first test range is 10 to 10. So all data are 10 only. Whereas in the second test, range is between 8 to 12. So it range is 12 minus 8. So the maximum value is 12, minimum value is 8. Like that you define the range, right? In the last one, maximum value is 15. So minimum value is 5. So it is spread over 15 minus 5. So range is 10 in this case, right? So this is for the ungrouped data. So like then what is the ungrouped data definition of range? It is the maximum value minus the minimum value. Then for this example, what will be the range? This is an ungrouped data. Yes, so it is already in the order. So first you make it in the order of increasing order. That means you make them in ascending order. First one will be the smallest one, then like that you move on and go up to the maximum value. So you will, if you range it, it is 3, 5, 7, 8, 12, 14. Then range will be 14 minus 3, it is 11. Correct? Now, what if you have the data in group form? So in this case, what will be your formula? So for the case of a group data, range is equal to upper boundary of the last class minus lower boundary of the first class. Yes, it is very natural to understand that range means from data is spread over from where to where. So that means the maximum value is 50. what is that? It is the upper boundary of the last class. This is the upper boundary of the upper boundary is this side 50 minus lower boundary of the first class. That means this is, so this will be the value. So 50 minus 0. So in this case, range is equal to 50 minus 0 is equal to 50. Got it? So yes, the range is this. Then our next variation is quartiles. What is a quartiles? Now the quartiles are the values that divide a data set into 4 equal parts, each containing 25% of the data when the values are arranged in ascending order. They help in understanding the spread and center of a dataset and are particularly useful in identifying skewness and outliers. Now we'll discuss. So what are the quartiles? So first you make the data in ascending order. Like your data are in ascending order and you make them uh, in this series, right? So your data are there in ascending order. Now what are quartiles? It divides the whole data set into 4 parts. So for that, what you do, what you have to do, so if you want to divide the whole data into 4 parts, so you need 3 values. One is here, this one is another one, this one is another one. So if you have, so this line, it is dividing the data, this 3 points divides the whole data into 4 parts, right? So basically these are the quartiles. So this is some point which is Q1, the quartile 1. This is some point which is Q2. This is something which is Q3. And it divides the whole data into 4 parts. 25% here, 25% here, 25% here, and 25% here. Right? Now we have some formula to find this Q1, Q3 values. What is that formula? So your first job is arrange the data, right? So you sort the data points in ascending order. Arrange the data in ascending order from smallest to largest. Then what is the formula for Q1? Q1 is equal to n plus 1 by 4th value, right? So it is the, so data you will have, correct? Ungrouped data. We are talking about the ungrouped data. So the data point you will have, then the n is the number of data is n. Then you take n plus 1 divided by 4, fourth value of the data. So that will give you the Q1 value. So this is Q1, this is the n plus 1 by 4th value of the data, correct? So this Q1 value below 20%, below which 25% of the data lies. Yes, that's what we have seen, that this is the Q1 point. So below which 25% points are belonging, correct? So this is how you will see. And one more thing. Now, if you see that n plus 1 by 4th value, now suppose somewhere your Q1 is maybe n value is equal to maybe your 12. Suppose n is equal to 12. Then n plus 1 is what? 13 by 4. Correct? So 13 by 4, is it an integer? It's not an integer, right? What is the value of it? 4 3s are so 3.25. Now, what is the 3.25th value? You don't have such value, right? Because it's not an integer and you have an ungrouped data. So in this case, what you have to do, you have to interpolate. I'll just talk about it, how to interpolate that, right? In the next slide. So now you just come to know that what is Q1 and then what is Q2. Q2 is the same way. You find the n plus 1 by 2th value of the data set. And Q2 is somehow the middle value of the data set. Yes, Q2 is the somehow the middle value of the data set. Yes, if you see the example, Q2 is somehow the middle value of the data set. So one side inside, another side this. Then what is Q3? Q3 is equal to 3 into n plus 1 by 4th value of the data set. And below this Q3, there are 75% data are there below Q3. And 25% data are there above Q3. Right? So, as I mentioned that if your this n plus 1 by, into 3 by 4th is not an integer, suppose it is 3.25, what you have to do? You have to interpolate to get the value. Now, what is, if you get that 3.25, what you have to do? So, value at the position 3 plus 0.25 into value at position 4 minus value at position 3. Correct? Now, again, if somewhere you got 5.50, this, suppose Q2 is equal to 5.50th value of the data set. Now, this is not an integer. We have to interpolate the value. How to get the value then? So, in this case, the value is equal to The first you take the fifth value at the position 5. So fifth position, value at fifth position plus 0.5 into value at sixth position minus value at fifth position. So value at sixth position minus value at fifth position. Correct? In this way, you will get this Q1, Q2, all this value. We'll do examples. No need to worry. Then there are another concept called interquartile range. What is that? So interquartile range is the value, the range between the third and the first quartile. It is called the interquartile range. Now it has a significance. First of all, it is, you are saying it is IQR, interquartile range, denoted by IQR. It is equal to Q3 minus Q1. Now, you look at that. We say now that whole data set, this Q1, Q2, Q3 is divided the whole data set into 4 parts. So Q1 is somewhere here and Q3 is somewhere here. Now, if you do that Q3 minus Q2, so it is taking only these values. It is taking only these values. What are they? Are they not the represent the middle 50% of the data? So are they not the represent the middle 50% of the data? 25% here, 25% here, right? So this interquartile range has a significance. It represents the middle 50% of the data. And good part of it is, now suppose in your data you have a outlier. What do you mean by outlier? A value which is very extreme other than the compared to the other values. So suppose you are finding the average value. So most of the student in a class has birth age maybe that 19 to 20 years. But there is a student who maybe came late, he was doing job and want to do something, some BTech again or some other degree program, and who is having 55 years old. It possible. So once you take that student age, and then the class average will be drastically up. But it is for only one student, whole average marks is getting, whole average age is getting high, right? So this kind of cases we called it outliers. We discussed it earlier as well. Now, then if you have a outlier, that outliers will be somehow maybe in these places. If it is too high, outlier may be somewhere here if it is too less. But the middle value will not change much, right? So if you have calculate the interquartile range, so the outlier cannot affect them, right? So in this way, we can say that it is a robust measure of the variability less affected by outliers. I hope you understand. So this has a significance. Now we'll do some example. Now look at this example. How to find the that all the quartile value. First of all, you count how many data points are there. It's an ungrouped data. So here n is equal to 8. And your first job is what? You make the data in ascending order, right? So what you will do? It is 10, 10, 2 times 10s you have, then 1, 2 times 20, then 32 times. Then what? We have 2 times 30, then 150 and 170. So there are 8 data. Then what is the quartile formula? So Q1 is equal to n plus 1 by n plus 1 by fourth data, right? This is the fourth data value. Right. So but n plus 1 by fourth is what? It is 9 by fourth, which is 2.25. Now what is the 2.25 data? It is not an integer, right? So this is the 2.25 data. But 2.5, this first data is this, first data is this one, second is this, third, this fourth, fifth, sixth, seventh, eighth, like that it is there. But what is 2.25 data? It is not an integer. So what we will do? We have to interpolate them, right? So what is then Q1? Therefore, Q1 is equal to, first you say that it is the second data. We have to interpolate the data between second and third value. So the second data point plus we have to interpolate, so 0.25 into the third data minus the second data, right? Now what is the second data? It is 10 plus 0.25 into what is the third data? It is 20. So it is 20 minus the second data is 10. So if you just simplify it, it is 10 into 10.25. So it is, if you calculate it, it is 10 plus 2.5. which is equal to 12.5. So this is your Q1 value, right? So your Q1 value is 12.5 in this data. I hope it is clear. Now similarly, what is Q2 value? Q2 is the formula here was n plus 1 by the formula was n plus 1 by 2th value, right? So again, if you calculate n plus 1 by 2th means it is 9 by 2th. That means it is 4.5th value. Now 4.5 is what? So we have to again interpolate it, right? So therefore Q2 is equal to fourth value. Sorry, it is fourth value. 1 second. Yeah, it is the fourth value plus 0.5 times the fifth value minus the fourth value. Right? Now what is the fourth value? It is 20 plus 0.5 into what is the fifth value? It is 30 minus 20. And in this way 20 plus 10 into this, right? So it is 5. So this is the 25 is the Q2 value. Right? So at the same way, if you calculate the Q3, we will get the Q3 is equal to that is the Q3 formula was what? It is just a minute, I will show you the Q3 formula. It is 3 by 4 times n plus 1th value. So 3 into n plus 1 by 4th value. Right? So if you calculate, you will be getting the Q3 is equal to 45. Again, you have to interpolate. It is 6.75 value. So again, you have to interpolate. So it is 6th value plus 7th minus 6th into 0.75. So finally, you'll be getting this value is 45. Right? And then the question was, what is the IQR interquartile range? It is Q3 minus Q1. So it is 32.5. Right? So your data was in order. Now you said that 12.5 is where? Somewhere here. Right? And next value is 25 is where? Somewhere here. And 32.5 is where? Somewhere very close to here. Now see, it is dividing the data into 4 parts. Right? So Q1 is here, Q2 is here, Q3 is here. And Q3 minus Q2 gives you the middle values of the data. I hope it is clear. Very easy. So if you know the formula, so you can do it, and how to interpolate it. I hope you understand. So similarly, I kept some more examples. Look at the formula. So you can do the same thing. Right, first make the data in order. It is already in there, and if you put the formula, you'll be getting this answer. So this is for your practice purpose, we keep it. So please do practice just without seeing the question answer. You just do it by your own and then check the answer. At the same way, we have given for this value also, this example. For the ungrouped data we discussed. Now there is a natural question. What if you have the group data? How to find the quartiles? Now for group data, the quartile formula is this one, that Qk is equal to L plus Kn by 4 minus capital F by F into H. Right. So that means what is this K? K is the Q1. So in this case, what is the Q1? It is L plus, in place of K you have to put 1. So L plus N by 4 minus capital F divided by small f into H. Right? So Qk is the kth is the quartile, N is what? Capital N is the number of observation. Now you have to also define the quartile class. Now this kind of discussion we have done it in case of a mean mode median calculation. Right? Similar kind of problem was there. In median calculation, it is the similar kind of a formula was there, if you remember. So you have to identify what are the quartile class. Right? Now what is the quartile class? It is the first class interval for which the cumulative frequency is greater than or equal to Kn by 4. So Q1 class is what? It is N by 4. Right? The first cumulative frequency is greater than or equal to N by 4. Then Q2 class is what? 2 into N by 4. The first cumulative frequency which is greater than or equal to 2 into N by 4. Like that you have to define the quartile class. The next is what? L. L is the lower boundary of the quartile class. So once you have defined the quartile class, once you have identified the quartile class, what is L? You can able to get it. What is F? F is the cumulative frequency before the quartile class. We will discuss one example. So F is that. Small f is what? It is the frequency of the quartile class. What is H? H is the class width or the size of the interval. and kn by 4 is the position of the kth quartile, right? So let us just do one example so that it will be very, very clear to you. Now look at this example. Now, so your first job is to, you have to identify what is the quartile class to get the quartiles, right? So your Q1 first, if you identify, so first of all, what is your N? How many data you have, data points for this example? So it is the, just you have to add all the frequencies, right? So N is equal to 50 in this case. If you add all of them, so there are 50 data. If you add all of them, you will be getting, this is a 50 numbers of data you have. So your capital N is equal to 50. Now what is the quartile class? So for that you have to identify Kn by 4, right? So for Q1 class, how to do? So for Q1, the first quartile class, we have, it is N by 4th value, right? N by 4 is equal to what? It is 12.5. So then what was the quartile class definition? I'll show you again. The quartile class is the first class interval for which the cumulative frequency is greater than or equal to Kn by 4. Cumulative frequency is greater or equal to N by 4. Now see, what is the cumulative frequency is greater or equal to N by 4? It is this class, right? So Q1 class is this one then. This is the Q1 class where cumulative frequency is just greater than or equal to N by 4, right? So therefore, we can get the other values. What is L? L is the lower boundary of the quartile class. So L is equal to 10. Next is what? Capital F. Capital F is what? So it is the cumulative frequency before the quartile class, which is this one. So this is 5. Next is what? You have to get small f. It is the frequency of the quartile class. So this is 8. Frequency of the quartile class is 8. Next is what? You have to the width of the each class, which is 10. Right? Then the Q1 formula is what? Q1 formula is equal to L plus. So L plus, let me write Kn by 4, but K is 1 here. So N by 4 minus capital F divided by small f, right, into H. Now just put all the value. It will be 10 plus the values are 12.5 minus capital F is equal to 5 divided by small f is equal to 8 into the width is equal to 10. Now if you just simplify, you'll get the value is 90.375. Clear? So the same way, can't we calculate the what is Q2? What is the Q2 class? Let us identify again. Just I will discuss the first part, and same way we can do the thing. Now what is the Q2? To find the Q2, for Q2, maybe I'll do it here. For Q2, it is 2 into n by 4 we have to calculate. So 2 into 50 divided by 4, that means it is 25. Now quartile Q2 class is what? It is the cumulative frequency when it is more than or it crosses the 25 to n by 4. That means this is the first one. So in this case, the quartile class Q2 class is the whole this class. Then the same way, what is the L here? L is equal to 20. What is F here? The cumulative frequency, it is 15 plus 13 plus 5. Right, maybe it is there only. Yeah, so in Q2, it is the 25th one. So the Q quartile class is this class. Quartile class is this class. And then the same way we can do what is L. In that case, L is equal to 20. F is equal to the cumulative frequency before that. So 13 plus 5, it is 18. Right. And then, okay. And then, okay, sorry. F is equal to, not that, it is the frequency before the quartile class. I'm sorry. Okay. Just a minute. Therefore, Q2 is equal to F plus this. Just a second. Yes, sorry. So your Q2 is F is the cumulative frequency before the quartile class. So it is 13. In this case, it is 13 because 8 plus 5 it is 13. So it is 13. And then same way, small f is equal to frequency of the quartile class. Yes, it is 15. And then the h is equal to width. So all these things are same. And if you put it in the value, you'll be getting this value is 28. At the same way, you can also get the value of Q3. The same thing. So the Q3 is that 3n by 4 is this one. So the Q3 class is that 30 to 41. This one is the Q3h class. And then put the value L, F, small f, H, all this value if you put, you will get this Q3 is equal to this value. And finally, the interquartile range, it is the Q3 minus Q1 value, which is 16.565. I hope you understand. So this formula, you must have seen it in median calculation. It is similar kind of thing. So if we have already seen that your Q2 is actually the median, it is giving you the median value. So put k equal to 2, you'll be getting it as the median. Right? So we have given what example, more example for your practice purpose. Just look at the example, solve it, and another example is also given. So both the example you please practice so that you will be habituated how to do this problem. Right? So there you have to complete the table. So make the cumulative frequency one more data and get the values. After that you have to all this calculation Q1, Q2, all this. Right? I hope you enjoyed this. It is not at all tough. You just have to do carefully all these calculations, and these things are basically easy, but you have to do carefully. If you do mistake in some places, it will be affect the whole table. Right? So slowly, carefully you do. I hope you enjoyed. Thank you very much. We'll come up with the next video. In the next video, we'll come up with the next few more variations. Thank you very much.